in the Extension 1 course, we're going to learn new ways, more methods for integration, because they're pretty limited compared to differentiation in the 2-unit course. So naturally, there's harder functions that we want to integrate, but we don't have the capacity in the 2-unit course. So we're limited in integration. In the Extension 1, like what we want to do now is look at using a substitution. What we're basically looking at here is reversing the chain rule, and this is what this process will do for us. So, like, we're looking at something like 3x squared, integrating 3x squared outside of x cubed minus 1 to the power of 4. Now, by itself, if you could recognize it, like, that would be that's the derivative outside of it, and then so it needs a manipulation in terms of the chain rule. Then you could do that. Like Extension 2 kiddies, you're going to be expected to do something like that to recognize it. But in Extension 1, what we're going to do is get the substitution to play with. So, and we can see that there's a reversal of the chain rule, and it's needs a 5 out the front, and sorry, 15 there, and a 1/5 out the front to do this. But it's what we're looking at in terms of this method. So let's have a look at what we need to do. So what we're going to do is we're going to have a substitution given to us that we need to make. So we're going to look at the idea that we have to integrate something like 3x squared x cubed minus 1 and be told what to integrate. So we're going to do a substitution of some variable. We're substituting in for x. Now, the only problem is that when we do that, if we substitute, then we get, well, u would be equal to x cubed plus 1, so that part would become u. We've still got 3x squared and the dx, because if we put this function in terms of u, we can't have it being integrated with respect to x anymore. It's got to be integrated with respect to u. So if we do look at this way, now what I want to do is look at our differentiation of this function u is equal to x cubed minus 1 as the derivative of one side of driving each side with respect to each variable. Instead of du dx, we're just going to write it as du equals to the derivative of that function times dx. So instead of the dx being on the bottom here and being like that, we're going to have it over here. So we're just going to write it that way. Only for the simple fact that we want to replace the dx as well. And notice that when we do the x cubed minus 1, we get 3x squared. So we're getting a nice substitution that we can go in there, and there's our 3x squared dx. And the dx du is going to cancel it there. So that's what we're looking to do when we do these types of questions. So when we do looking at these types of substitution, then so we substitute the x cubed minus 1, and the 3x squared dx becomes du. So you can see there's our substitution we made. Now we've got u du, which is much easier to integrate than what we had here before. So we can able to put that in and integrate to get what we need, and then substitute x back in. So if we have a look at the other, some more problems here. X outside the square root of 1 plus x squared dx. Well, that's going to be hard to integrate. We can't expand it out. We can't do much with it. So if we get the substitution of 1 plus x squared, du would equal 2x dx. So if you look and see, well, I've got an x dx, but I've got 2x dx. Let's manipulate it so I've got x dx. And that would be equal to a half du, just divided by 2. Then I can do that substitution. So x dx is equal to the half times du. And then 1 plus x squared was u, so becomes the square root of u, or u to the power of a half, which we can integrate u to the power of a half. So see what was very complicated now becomes much simpler by using a simple substitution there. So half u to the power of 3 on 2 divided by the 3 on 2. So the half and the 3 on 2 just gives us 1/3, and we can substitute 1 plus x squared back in for u. So that's the process we need to look at. So another example, x plus 1 over x squared plus 2x all cubed. Well, if we're given that u is equal to x squared plus 2x, that gives us 2x plus 2 dx is equal to du. Again, we want x plus 1 dx, so we divide by 2, so that would be equal to a half of du. And when we make that substitution, x plus 1 dx is a half du, and we're 1 over u cubed, which is u to the power of minus 3, over 2, add 1 to the power, divide by the power, so the 2 goes to -4, and then we're able to do our substitution back once we've integrated. So that's our process. Oh, we should have noted here, you should be given this substitution every time in the Extension 1 course. Extension 2, not so much. So, but substitution should come along when you've got to do a question here in Extension 1. So let's have a look at another question. So we're given the substitution of u is equal to x minus 1 all square, x squared minus 1. So du would equal 2x dx, and that's what we've got there. 2x dx would be equal to the du. So there's our substitution. X squared minus 1 to the power of 4 was u, so we can able to put that in. Now it's easy to integrate u to the power of 4 and do our substitution back. So that's what we're trying to do, and we're going to make it simpler to be able to do a substitution. U is equal to x cubed plus 4 becomes 3x squared. So now it starts to make our integration, our substitution possible, and then our integration much easier there. So question 3 here. This time u is equal to x cubed plus 1. So du is equal to 3x squared dx. So 1/3 du equals x squared dx there. So because we want to manipulate it that way, because we've just got an x squared dx, we haven't got a 3x squared. So we put our 1/3 du in there, and we get u to the power of with the square root, which is to the power of a half. Don't forget our integral sign, and then integrate u to the power of a half as we normally would, and then do our substitution back in. Just being careful with all the numbers. So again, we can see the process with this one, where we're going to use x squared minus 4 as our substitution, and du is equal to 2x dx, and we're able to manipulate it, so 2x dx is just du, and then we're able to get our u to the power of minus a half, because it was du on the square root of u, integrate, simplify, and put our value back in, and put our substitution back in there. Again, the same idea here. This one's a little bit harder for our substitution, but same process. X squared plus x plus 2 is 2x plus 1, which just happens to be what we have out the front. So that gives us 2x plus 1 dx is du, and then we've got the u to the power of 5, and the integration is very nice. So you can see, and if you're not sure if that's what it should be, then you can do the differentiation of this function. If you derive this function, you should get back to that. That will always work again. So in this one here, we got, again, substitution of 2x plus 3. So we get that being as du is 2 du, so 2 dx. And because it's just got the x there, we get that by itself, and that's a half du. Which means that when we do this here, the dx would be a half du. And then we do on u cubed, and so that becomes u to the power of minus 3. Integrate and put our power there, and simplify it out, and we get that function. Now notice I've done it here in this way because we could do that with 2-unit techniques. That's something we don't need to do with substitution. But hey, we can see that it works in that regard. So it's not a problem to do this process and see that. So there's our process. Have a look back through again if you're not sure. But every time you'll get a substitution, we need to get rid of the x's, but also we need to do a substitution for dx for this all to work.